This presentation is about REST services and some of the best practices that we have learned over the years while developing our REST APIs. We will start with some of the basics of REST APIs, which includes some of the basics of HTTP and some basics of what is REST and some of the features of REST. The best practice that we are presenting here are from our own experience and by going through some of the RFCs which are out there, as well as going through some of the REST APIs which are out there as well. We have developed against about 30 odd APIs or 30 odd REST APIs which we have consumed, and we have seen some APIs which have very good uh, practices that have been employed in them, some APIs which are not that user friendly at all. And using all that experience plus the experience that we have gained developing our APIs, we have come up with certain best practices that we currently use in our API development. And this is a snapshot of some of them, not all of them, but we believe if these best practices are followed, then the APIs that are developed would be more in tune with the REST architecture and would be much more helpful and much more client friendly. So about myself, I work as the Chief Technology Officer for REST Gateway Incorporated. REST Gateway is a travel domain company. We develop solutions and software for travel sector. You can visit our site at www.restgateway.com. So I've been in the industry for about 13 years, specializing in JEE, enterprise architecture, web services, and these days I'm primarily focused on some API development, which are more into REST and REST architecture. What we will cover? We will cover some introduction to HTTP and we will cover some introduction to REST, but the bulk of the presentation is going to be about the best practice of building REST services. So what is HTTP? HTTP stands for Hypertext Transfer Protocol. Hypertext is simply some structured text that uses links. So if you download an HTML page into your browser and you do view source, what you're seeing is hypertext. In that you will see HTML tags, which are plain text, plus you will see links to CSS files, to images, to JavaScript, so applets. So these are the links, so the hyperlinks which are contained inside hypertext. HTTP defines a set of rules, or it's a protocol basis, so it's a set of rules or constraints which governs how hypertext gets transferred between or within the World Wide Web. And in World Wide Web, everything is basically either a client or a server. So the communication is between a client or a server. So we say HTTP is also a request response protocol for client and server architecture. So in essence, hypertext is structured text that uses logical links and hyperlinks between nodes containing text, and HTTP is a set of rules or constraints that governs the exchange of hypertext between a client and a server. So this picture represents in a nutshell what HTTP would be doing and how HTTP would work. So you have a client which we call a user agent, and then you have a server, which is an originating server. So you are sending a request and receiving a response from a server. So in between this, though it looks very simple and you only have a client and a server, in between this communication, the request and the response has to go through so many intermediaries. Intermediaries are like proxy servers, gateways, routers. These are not under our control. So to make sure that everything works without any problem and seamlessly data can go from one end to another end and then come back or return back to the client, HTTP gives a set of rules. If we follow those rules, every intermediary would know how to work with our data packets. So between the client and the server, we send requests which are hypertext or hypermedia, which could be HTMLs, images, CSS, text, etc. And HTTP governs the rules which make sure that data or your request and response work seamlessly back and forth. What is REST? REST stands for Representational State Transfer. REST is an architectural style. Most people or some people believe that REST is a framework or it's a design pattern. but actually it's an architectural style. The difference being a framework means you are given a set of rules which you have to follow. You cannot go outside of those rules. An architectural style means you are given a set of constraints. If you follow, your end product would be more in line with the architecture that has been defined. But it does not say this is be all and end all. That means either you follow this or you cannot develop or you cannot do REST. You can still have REST, but or you still can have a REST-based API or REST-based service, but that REST-based service may not be fully REST or aligned with fully REST if these architectural styles are not followed. It also defines, REST also defines a set of rules. As I mentioned, HTTP has a set of rules. So REST goes hand in hand with HTTP. So the rules or the constraints of REST are in line with HTTP. So it defines a set of constraints or rules for distributed hypermedia. And also HTTP 1.1 was designed with REST in mind. So right now in the World Wide Web we use HTTP 1.1. So in essence, the whole World Wide Web right now we can say is a REST-based architecture. Some of the features of REST. REST is resource-based. A resource is anything that you can name. So for example, a list of hotels, a list of users, what is the traffic like in Los Angeles, what is the weather like in New York. So all these are resources. So if you ask from a server, give me a list of hotels, you are asking for a list of resources. Or if you ask, okay, what is the weather like in Los Angeles, you are asking for a resource. If you ask, give me the book Alice in Wonderland, you are asking for a resource. So you are always working with resource in REST-based architecture. REST also defines representation. Representation is the current state of the resource. So for example, if you have a book in your service and if you say, give me Alice in Wonderland, you are actually getting a state, a representation of that resource. Now the representation may be part of the resource or the resource as a whole. So for example, if I have a resource called person, and if the representation of that resource person would be the name of the person, address, contact details, uh, but it may not contain height or let's say the skin color because that is not within the context of the application or the API. If it is a hotel, if you say okay the resource is hotel and if you say give me a hotel, give me Hilton Marriott, you would get the name of the hotel, the address, the location, the geocoding, how many rooms, what sort of amenities are there in the hotel, what are the attractions nearby. But it will not have the color of the hotel or when it was built because it may not be in the context of your API. So it could be the resource as a whole or it could be part of the resource depending on your API and depending on the context of the service. In REST, everything is identified by a URI. A URI is a global way of reaching your resources. So you reach your resource by hitting a URI or typing a URI in your browser from the client. HTTP has several behaviors or verbs which we say like get, post, put, delete, head. REST also uses the same HTTP behaviors. And it has hypermedia. Hypermedia is the format of data which you pass between the client and the server. So it could be something like XML, it could be plain text, it could be JSON. So it's a format specification. And also it's a passing rule. That means with hypermedia or media types, sorry, not hypermedia, with media types, you can define once the server gets your data, how the data should be passed, how the data should be handled, what should be done with the data, and vice versa. For example, when you get data from the server can define when the client gets the data, how the data should be passed and how the data should be used. So if we relate REST to programming, software development, a resource is like an object in object-oriented programming. Representation is the current state of the resource or the current state of the object. And your objects may be identified by certain IDs or certain unique attributes in your object. In REST, a resource is identified by a URI. in your object-oriented object, you have methods like get username. If your object is user, you would have get username, set username, get address, set address. So you have user-defined methods. Whereas in REST, your resources are handled, or your resources are worked with HTTP methods. So HTTP behaviors like get would get you the resource. Post would allow you to update or change or create a new resource, or put, delete. Like this, you have to use HTTP behavior. So there's a limited number of behaviors compared to an object-oriented object. Right? So in essence, that's how you can relate a resource or a REST object to an object-oriented programming object. The 6 constraints. We said that HTTP had a set of rules and REST also follows those rules or those constraints. So these are the constraints. These constraints are there in order to make sure that your data which you travel between or travels between your client and your server does what you expect it to do. So the first constraint is uniform interface. That means your communication or your REST API should define a specific uniform way of communicating between the user and the agent. That means you are going through so many intermediaries while you're going from your client to your server or back. So when you're going through these intermediaries, you have no control of these intermediaries. So there's a global set of rules or interfaces defined for all these intermediaries. So your data should identify there is going to be intermediaries, and these intermediaries follow these uniform interfaces. So I have to understand that, and my API and my service should work with those interfaces. For example, the HTTP verbs. So your API should work with these verbs. And when it works with these verbs, according to the way they should be handled, which we will cover in our best practices, then your intermediaries will work exactly how you want them to work. You have URIs. So your URIs is how you get to your resource. So you have to make sure that your URIs are properly defined and properly used. HTTP requests, HTTP responses, these are uniformed interfaces. So all the intermediaries know how to handle them. For example, an HTTP status code. Every intermediate know how to handle the status code. So your API should also have a way of using those status codes exactly the way they should be used. Statelessness. This specifies the server and client contains no state of each other. So for example, if you take a browser, the browser will be, if you take a browser and you, let's say you type www.yahoo.com, it will download an HTML. And then if you go inside the site and you go to the current news or the latest news in Yahoo, your new page will not have any state in the browser about your previous page. For example, when you load news and you get news getting loaded, your browser does not right now know anything other than what is being loaded right now. So the message itself has to have information or descriptions to tell what to do. So statelessness means you do not keep state within your client or your server. Each message should be descriptive enough for the client to understand what to do or the server to understand what to do. It assumes that you have a disconnected system, so client server. So HTTP is a protocol between to transfer data between a client and a server. So REST is also the same. REST is piggybacking on HTTP. So REST also defines that your communication is always going to be between a client and a server. And REST assumes that your data or your responses from your server are cacheable. That means your data which you're sending from your server could get cached either in your clients or your intermediaries like your proxy servers or gateways or routers. When you're developing a REST APIs, you have to always remember that you are going through multiple intermediaries. So you are working with a layered system. So how your intermediaries will work, you would need to know, or by and large, what are the constraints of those intermediaries like your proxy servers or gateways which are in the net. When you communicate with your clients, you would need to know, you have to go through them. So you have to make sure that you define your API and you design it in such a way that it will work with these intermediaries. We will get more in depth into this when we go through best practices, so you will know some of the best practices of how you can use your APIs to work with these constraints. There's another constraint as well, where we can say that your server can extend the client by using source on demand. For example, when your browser loads a JavaScript, the JavaScript can do something in your browser. Maybe it can do some validation. Maybe it can do some graphic animations. So those are ways the server can send you certain information and extend the browser to do more work. A good example would be an applet. With an applet, you can have security with the client. You can do certain things with the client, or even ActiveX control. So you can extend using hyperlinks. You can have source on demand, which extends the client. Server can temporarily extend the client. So by following these rules, you get more or less a REST architectured API or a service. And by doing this, you achieve scalability, simplicity. Scalability in the sense, we really don't mean like increasing the number of load or the hits on the server, but more or less how you can scale your application, how you can uh, let's say go from one media type to another media type, how you can go from an enterprise level to a mobile level API. So you can scale much more easily. And simplicity. Your APIs become much more simple because it follows HTTP, which is a simple protocol. Modifiability. Easily you can modify it. Visibility, portability, reliability. These abilities you get by following these constraints. So let's get to some of the best practices. First one is resources. How do you work with your resources? First thing that you'll remember is a resource is actually a noun. It's not a verb. So when you're designing your APIs, make sure that your API resources are designed or defined as verbs, sorry, nouns. For example, uh, hotel is a noun, book is a noun, user is a noun. But get hotel, get books are not nouns. Those are verbs. Those are actions to do. So for example, your REST API should not have service method saying get book, set book, get hotel. It should just have hotel. So your entry point, an example entry point or your service method could be api.restgateway.com/hotels, and you get a list of hotels. api.restgateway.com/hotel/id/Hilton Marriott, or name/Hilton Marriott, hotel/Hilton Marriott. So you are getting a specific instance. But you should never have api.restgateway.com/gethotels or get hotel Hilton Marriott. That will not work. So you have to work with nouns. Also, you have to make your nouns or your service methods coarse grained. For example, coarse grain and fine grain. The difference is, if you take fine grain means you are being very specific. So if you take the same object-oriented example that we used, if you say user is an object, get username, get address, set address, these are fine grained methods. The problem arises if I want to only get the first name or change only the first name. Then I would need to have methods in my service saying get first name, set first name. So it really, if you go into very fine grained service methods, your API or your web service is going to get very soon bloated like nothing. You're going to have so many service methods. So always it's better to use coarse grained resources. For example, you use the resource as a whole. So you say, okay, if you want to get the user or set the user, or if you are working with users, so you just have user. And if you use a get method or a get verb, you will get the user. If you use a post verb, you can update the user. So the client can send the full user. And then you can use put or patch. Patch is for partial updation. So you can use coarse grain methods. So it's better to use coarse grain methods. And also, if you take resources, there are two types of resources. There are collection resources and there are instance resources. A collection resource gives you a vector or a list of resources. An instance resource gives you a single instance of a resource. So in your API, you may have to tackle both of them, or you may have to have endpoints to both of them. So you have to do your resource naming accordingly. So if you have if you are, let's say, working with books, then you may have an API call called api.restk.com/books, which will give you books, or it will say api.restk.com/book/A1B1C1 or Alice in Wonderland. Then you will get only that book. URIs. We mentioned that URIs are the fundamental way of identifying resources in your REST API or your REST service. So when you're defining your URIs and when you're designing your REST API, you have to keep these in mind in your URI. URI should be global. That means it should have a global scope. It should not be local to a single scope only or a certain area. It should have a global scope. It should not be ambiguous, right? There should not be any ambiguity in your URI or your URI. It should be resolvable. That means we normally say the name of the thing is how we relate to it. So by looking at the URI, we should be able to relate what this URI is telling us. So if you take these two examples, the first one says api.restgateway.com/hotel 1234567. This is a global URI. You can access from anywhere. It's having a global scope. It is not ambiguous. You are saying you want hotels and you want a hotel and the hotel is 1234566. Now the problem is this. Problem is I do not know by looking at the URI what is 1234567. Is it the ID of the hotel? Is it a phone number? Is it a group ID? Or is it some unique reference which is there in the hotel? So I do not know that by looking at the URL. So I cannot relate to it. I cannot resolve it. To relate to it or to resolve it, if I use the second URI where it's api.restgateway.com/hotel/ID 1234567, then I know this number is the ID. Then by looking at the URI, I can relate to it. Think of a book. If you take a book, you have the ISBN number. Now ISBN number is global. There's only one ISBN number per book. So it is not ambiguous. But if your URI says api.amazon.com/books/ISBN number like 1234567, you would not know what that 1234567 means. But if you say books or book/ISBN/123456, then you know that number is the ISBN number. Then it becomes more resolvable. So most of the time what we are seeing is APIs have URIs which are global, which are not ambiguous, but sometimes it's very difficult to relate to what that URI means by looking at it. So then it becomes very difficult for the clients, very difficult for the users. We have seen this in practical when we were practically consuming certain APIs in our organization. So make sure that when you are defining a URI, your URI can be resolved by just looking at the URI. That's what you call a resolvable name. And your URIs, make sure those URIs are short and simple and can be easily or quickly identified. So for example, api.restgateway.com is much more better than www.restgateway.com/services/rest/v1/hotels. Also, if you look at the second bullet point, you have api.restgateway.com/hotels versus api.restgateway.com/hotels/hotel.cgi or hotel.do. Now, when you use hotel.cgi, hotel.do, you are binding your URI with underlying technology or your framework. What happens is, over a period of time, we may change technology. We may change the framework that we use. So in essence, if you bind your URIs to your technology or your framework, then when the framework changes, your clients will have to change, or you'll have to have multiple entry points, one for the old technology and uh, a new one for your new technology, so that you'll have to do a redirect from your old URI to the new URI. Also, look at the last URL or URI where it says api.restgateway.com/hotels ?groups Marriott. Now this URI is actually trying to give you the hotels which are in the groups Marriott. which is one way of using it. But if you really look at it, you are limiting your URI. You are not in a position to expand. But whereas if you look at the second one, api.restgate.com/hotels/groups/Marriott, now you're expanding a URI. So it can be hotels slash groups slash specific or special groups, and then you can have groups. So you can expand your URI. So it's a better way of drilling down or mining into your resources rather than using query strings with uh, criteria. So in essence, make each URI meaningful, expandable, long lasting, and decouple them from the underlying technology. Verbs. Verbs are HTTP behaviors. So when you're using your verbs, make sure you know how to use those verbs and use them properly. So a get method, which is a safe and idempotent and cacheable method, is used only for getting resources from the server. It is not used to updating or changing the resource, because normally the uniformity is get is safe. That means if you use get, everybody assumes, all the intermediaries, everybody assumes you are not going to change the server. So in essence, if you use get and you connect to a service and you go through so many intermediaries like a proxy server, the proxy server would see, okay, it's a get request, so it's a safe request, I can cache this request. Now what will happen is the response that you get could get cached. So you run this get to create a new resource, and you run this 100 times. You would get resource created successfully, but you may not even be hitting the server, right? And idempotency means you can run this, you can run a request 100 times. You will get the same format of response. So for example, if you run api.restgateway.com/hotels, you will always get a hotel list. The hotels inside that might change, but you will always get a hotel list. And at the same time, post is neither safe, neither idempotent, or neither cacheable. Post is simply used to create resources. You can use post to update, but the recommendation is to use for creating. Put is idempotent, and put is used to update an existing resource. Delete is used to delete a resource, and it is idempotent. Now you can use get or post to delete. You can use post to get resources. You can mix and match. It is up to you. But the best behavior or the best practice of using these behaviors is to use them as they are supposed to be used. So your intermediaries will work without any issue. Content negotiation. Content negotiation means how you negotiate your content between the client and the server. Look at the first three URLs. If you are currently having XML and you're deploying XML in your API, your clients could connect to your API saying api.restgateway.com/hotels.xml, which will give an XML content. But later down the line, if you change the types, if you change the way you handle, and then you go with JSON, now the URI changes. So the way that the client can say, okay, I want JSON would to say hotels.json. The problem here is, as you keep changing, as you keep evolving, you will have to have so many entry points, so many resource web methods or entries created for each content type that you're sending out. So a better way of handling this is to handle them in your request headers. That means in your request header, the client can say, I accept JSON, I accept XML. And when your server gets this request, your server can actually go inside the request header and see what is being accepted. Okay, it is accepting JSON and it is accepting XML. The order of preference is first, if I have JSON, send JSON. If I don't have JSON, I can send XML. If I don't have any of them, I have tackled it separately in a different way. Current APIs, current JAX-RS implementations like in Java or .NET implementations have their way of identifying these request headers by using certain annotations. For example, if it is in Java, the annotations would be consumes. I consume a certain type, so my API consumes JSON, my API consumes XML. So when a request comes, it will check whether you have XML or JSON. If not, you can handle it separately. But the content negotiation comes with the request header. At the same time, if you want to have different types of languages, or you want to become multilingual, you can send your specific preference of language with accept language. You can say I accept English in your client request header. So when the server gets the request, it can see, okay, this request is accepting English, so I will send my content in English. At the same time, if I send FR for French, I will get the accept language, and I will, if I have French content, I will send French content. You can even use this for compression. You may develop your API for enterprise clients who are not really caring about the content that is, or the size of content that is going back and forth. So they may just use uncompressed data. But later, if you get a mobile based client and they really do care about the size of the content, then they might want to have compression. So in the encoding or accept encoding, a mobile client can specify gzip. Then the server can get the request, identify the content encoding is gzip, and the server can send gzip or compressed response. At the same time, it can handle enterprise clients who are not sending gzip in the encoding and then give them uncompressed data. Now, one important thing to remember is this: if you are supporting different types of encodings, or you are accepting different types of content, you will have a problem with your intermediaries. The situation could be something like this. Assume you are using a get statement, and in a get statement you are requesting let's say a JSON request. So the client sends to the URI api.restgateway.com/hotels asking for JSON response. So now the server gets the request, server identifies it's a JSON response, server sends a JSON payload, a list of hotels in JSON format. Now this whole thing does not happen directly between the client and the server. It happens between a client, set of intermediaries, and the server. So let's assume you have an intermediary called a proxy server. Now the proxy server gets the request, it identifies the URI as api.restgateway.com/hotels, and the server is sending a successful response 200 status, and the data is there. So the proxy might decide to cache for this request URI. This is the payload. So this is the response, and it will have that in its cache layers. Now assume a second request comes by another client, and that is requesting XML. So now what would happen is, when that request comes to the proxy server will see the URI. URI is api.restgateway.com/hotels, and since the URIs are matching and the data is cached, and the data just came about 1 minute back, what the proxy server might do is to send that response or that payload which is cached right now to the XML client. But the problem is, XML client requested XML but is getting a JSON response, a JSON payload, and the client may break. So if your API is supporting multiple or different types of content, you have to say my API is supporting varying content and send a vary tag back with the response header. So when the intermediary get the vary tag, it will identify the API is varying its response depending on the request header, or depending on the encoding. Then what the proxy servers or the intermediaries would do is, they will create separate cache instances and create compound keys. A compound key would be created using the URI and the headers, and then keep that payload only for that compound key, not for the direct URI only. So now when a JSON request comes, it will create a compound key, and in the compound key, one of the entries or the criteria for the compound key would be accept language JSON. So now that request or that compound key and accept language XML compound key would be different. So when the XML request comes, it will not give it from a cache. It will again hit the server, get the response, cache it separately as a separate cache entity, and send a response back. So if you are supporting varying content, you have to send back vary response. Versioning. Versioning means how you version or how you do version upgrades. Now, what we have seen most of the time is the versions are maintained in the URI. For example, your URI would be something like api.restgateway.com/v1/hotels. Now, this is the version 1 of our API. If the API is of version 2, it may become v2. Now, there are a lot of APIs like this. There is no issue with this. The only challenge being when you have to have when at a given time, if you have several versions, you will have to maintain those URIs until those versions get expired. So you are looking at a given time maintaining several versions. A better way of handling that is again through request headers or media types, where with the content type you can send what is the version that you are requesting. So you are saying, if you look at your request header, you are saying send me JSON content of version 1 or version 2. So your clients who are connecting to version 1 can send version 1 in their request header. Clients who want version 2 type of data and want to do version 2 types of work or API calls can say version 2. So the better way of handling that is to use the request header rather than using the URI. And also, since we use mainly JSON, we see that you can, like in JSON, you can always add elements. You can keep adding stuff so your clients won't break because there is no DTD validations like XML. However, if you're trying to remove an element, if you're trying to change an element, you have to make sure you do a version update and you make sure that you support the existing clients as well as the newer version clients. So in a nutshell, version upgrades are a very painful task for the client because they have to do the upgrade for the new version. So we have to minimize version upgrades as much as possible, and when you have to do a version upgrade, make sure you give ample time and you make it painless for the client as possible. Best practice for response body. One of the main problems that we have seen is when we are dealing with a lot of APIs and we are consuming APIs is date and time. So many APIs have their own date formats, have their own time formats, but the problem is depending on the client that we are using, sometimes it's very difficult to format those date and times into the format that we want. There is a format which is in the industry, which is ISO 8601 for dates and UTC for time. Every client understand this and they can format the date and time accordingly with their clients if the APIs use the standard formats, date and time formats. So in your APIs also always use ISO 8601 or UTC when you are sending date time formats. If you're using JSON, make sure that your payloads are camel case or use JavaScript notations because JSON stands for JavaScript. So use JavaScript notations and also try to keep things meaningful. When you're by meaningful, what we mean is by looking at the payload, by looking at the response that you get from the server, you should be able to make some or get some idea what this information is about rather than referring API documents and then going through pages and pages of documentation. For example, if in my API I'm sending the type of my rates and if I send type 2, nobody would know what type 2 means because your clients, they don't know what your API means. So how they have not digested the API in and out when they're starting to develop. So type 2 would be something that they would not understand. So they would have to refer an API document and then understand type equals 2 means this. But if you can send exactly what that means, for example, type 2 means non-contracted rates, then it becomes more meaningful for the client. So they know what the type that they're getting is non-contracted rates. Also, when you are having data or data elements, don't have them arbitrarily lying around in the response. Try to group them under parent elements. So for example, first name Bob, last name Singer. If you can group them under names, first name, last name, it is much more easier for the client to work with and it is much more meaningful. You can even have them as guest names. You can even have them as contact names or primary contact names. So it becomes much more easier and much more meaningful to the client. Uh, Handling prices, handling currency. We have consumed several APIs which sends us the price as we have shown in the here in this slide. Price $200. Now this is okay if I'm just going to display this price, but if I'm going to use this for any calculations, if I'm going to change the currency type, if I'm going to like a multi-currency system, then I have very big problem, because I will have to get this price value. I will have to string tokenize it, or I'll have to use some string manipulation and extract the dollar sign, extract the value, and then I have to identify what this dollar sign means, because dollar sign is meaningless to my client. The client would have to get that value, run through certain if conditions, identify dollar sign means USD. Okay, now I can do my conversion properly. But whereas if we can break it and send a price element as a parent element, and then have the attributes about that price. For example, what is the currency? USD. What is the sign to show? Dollar. And what is the value? 200. Now using this, I can manipulate my price, and I can do multi-currency, I can do calculations, whatever I want with this set of information. If I want to convert this to euro, I know I'm getting USD, so I can just convert to euro. Planning ahead. When we are developing, if you take agile basically says, okay, don't think too far, just do what you have to get by, right? Just do enough. But the thing is, when you are developing your API, if you just do enough, then when you have to change or when you have to extend, your clients will have a major problem, because the clients will have to change their code as well. So better way is to just plan ahead a bit, not much, just a bit, to know and to see and identify if you can see any elements that could extend in the near future, and appropriately handle your API. So for example, if you take what is here, you see address, line 1, line 2, city, state, which will work without any problem. The problem will come in later down the line if you get multiple types of addresses. So when you are developing this API, if you can see, if you can foresee that this API or this element will change over time or will extend over time, it is better to wrap it inside an array and send it as what you see here. So addresses, that means you will have multiple types of address, and each address has a type, and you can say default is this address. So now it's the same address that we have sent as we have seen in the previous line, but now you have given extendability. So what happens is, when a client develops the application with this in mind, even if you send different types of addresses like shipping, billing, later down the line in your API, still your client won't break. Whoever only wants to use shipping will still be able to use shipping, but if somebody wants to use billing, they can then use billing. So depending on what they want to use, they can use, but the existing clients won't have to do any change if they develop against the array. So it's not just the array, it's basically thinking what elements could extend or could expand in the future, and just thinking ahead when you're designing your API. Control workflow. You have to, as much as possible, control the workflow of your clients from the API end. So then you lessen the workload for the client. So for example, if I have an API call saying api.rescue.com/hotels, and I'm giving a list of hotels, and I identify my hotel or each hotel inside the list by ID, via an ID, then when a client wants to get to a specific hotel, the client would need to get my ID, which I am sending with the response. Then the client would need to build the URI for that ID and then call that particular URI to get that resource. So for example, if I am sending a list of hotels and assume Hilton Marriott's ID is 123456. If I just send hotel name Hilton Marriott, ID H123456, when the client wants to get to Hilton Marriott, that client would need to get the ID from the JSON response and then concatenate that with append that to a URI, and then only the client can get to the specific URI. Whereas in the payload of the hotel list itself, if I send the link to each of these resources, the client can just hit that link. They don't have to worry about string manipulations and creating, etc. Same way, if you want the client to do certain things, like for example submitting data, you can send what is the link to submit this data. Then the client does not need to keep that information with the client. They can just read, okay, what is the submit URL, just submit the data to that URL. Then you have more control, and lessen the load on the client. Same for pagination. For pagination, you can control from the server. So for example, if the user has to keep track of which page the client is right now in, uh, or what was the previous page, what is the next page, what is the starting value, what is the ending value. If I want to go to the last page, what would be the link I need to have? If I want to go to the first page, what would be the link I need to have? It is going to be a painful task for the client to maintain that. So your client is basically keeping the state of next and previous pages and all that. A better way of handling that is to handle this from the server. So with the server, you can send a control header or a control element where you say, okay, right now you are in this link. If you want to go for the previous link, this would be the link. If you want to go to the next page, this would be the link. If you want to go to the first page, this would be the link. Last page, this would be the link. So then what happens is the client will only have to just read those values and just run those links depending on the user. And you can say, okay, what is your offset value, what is your limit. So you can always tell the client how to handle the pagination or control the workflow of the pagination from the server itself. And this becomes more important or more necessary if you're using NoSQL data structures, because some NoSQL data structures don't have offsets and limits. They work with the keys depending on how you have set up the data. So in a situation like this, handling pagination by the server from your API itself makes it much more easier for the client. Resource linking. We normally say hypermedia in hypermedia. It's key that you can talk to different systems or different uh, hypermedia itself using links. So for example, if you take an HTML, you have links to CSS, JSS. So these are links. And in a resource model, for example, in your REST service, in a resource model, you would need to link with other resources from your current resource. For example, if you take a hotel, if your current resource is a hotel, then you would need to link to maybe groups of, or which group this hotel belongs to, or maybe the attractions nearby. So these are different links which you need to link up with, the resource which you need to link up with. So to handle this, if you're using an XML service, you have Xlink. If you're using JSON service, you can use things like HAL or Siren. But the problem is, what we have seen is these are very verbose. That means when you use these APIs, your response become bloated. So the information that is going is bit bloated. A better way which we have identified is to use simple links. So if somebody wants to get the links, they have the links as well. At the same time, if they want to get more information, they can use an expand tag, an expand criteria, and then you can expand the elements you want. You can even limit of this expansion what are the information that you need if you want to go that far. So if you take an example, if I say get hotels, and if I'm getting a single hotel, I send as a link the group this hotel belongs to. I can send attraction links, which what are the nearby attractions this hotel has, as links only. If I want to get more information, I can use an expand criteria in my link and say, okay, expand group and expand attractions. So when I'm sending back the payload with an expand, I can expand the information more about the groups and about the attractions, but leave out the amenities. I may not expand amenities. If the client says, okay, expand amenities, I can expand amenities. But whereas if you use HAL, Siren or XML link, you would have to expand and send by and large almost all this information. So a better way of controlling this is to use the expand tags and then to create your own way of handling resource linking. Error handling. This is another place where we see a lot of people having problems with, where the errors are not handled properly. The key thing to handle in error handling is to make sure that you use the HTTP status codes properly. What we have seen is most people, what they do is they send the error response as a response message, but the status goes as 200. Now the problem there is for the intermediaries. If you say, okay, uh, get me hotel Hilton Marriott or H12345, you hit the proxy server or the intermediary gets the URI, then the intermediary or the proxy server sends the request to server. Server does not have a hotel or Hotel Marriott. If the server sends back 200 status and in the message body gives a message saying hotel not existing, as far as the proxy server or the intermediary is concerned, it got a successful response. It may cache that. So if it does cache that, you will have a problem where you can now start hitting this resource 100 times. You will still get a page not found or a resource not available. Even after the resource has been created in the server, you will still have the problem because you are getting it from cache. So if you are handling errors, make sure paramount that you have your status codes properly going out, not 200. So for example, in this case, you can send 404. So you can say, okay, server response HTTP status 404. In your content, you can say hotel not found, contact this for more information and all that information. But your status HTTP status code has to be not 200 but like a 404. If you're trying to create a hotel and if you have an error and the hotel is already there, you can say 409, a conflict, or a 500 internal server error, but send the proper HTTP status code. And in the message, give all the information as much as possible, because your client should not have to go in between the traverse between the header and the message. The client should get all the information in the message itself. The header or the HTTP status is for the intermediaries. Intermediaries will not actually care what you have inside the message, but the message is for the clients or the client developers. So you will know in the message when a client gets that, client can just read that message and say, okay, it's a status 409, so I have got a conflict. The code that the organization or the API developers have put is res11111, and the error is hotel is already existing or whatever the error. And then you can even give a developer message where you can give a more technical message, and you can even give a link if they want more information about the error code that we are sending, like res111, what that means. So now for a developer, this is more meaningful, but for a intermediary, HTTP status is much more meaningful. So use, like, handle your errors properly. Use the message and the header accordingly, HTTP status accordingly. Security. Number one, avoid sessions as much as possible. Sessions in nature would have to use session ID to manage security. So a session ID in nature is not secure. If somebody captures your session ID, then they can participate in that communication. So do not use sessions if you have to have security. Do not use sessions to authenticate, right? Use authentication for all the requests, not sessions. Don't use sessions. Authorize based on content, not on the URI. That means we have seen APIs which have specific URIs that have been authorized. The authorization is for the URI but not for the content. The problem lies if you let's say migrate your API and your URIs change. Now you have to keep different security policies being added for each of these URIs. Instead of that, if you just look at the content and authorize the content, then no matter how many URIs change or how many migrations happens, still you are authorizing the content. So you make sure only authorized person can access that content, and it is authorized. It's not for the URI. Also, try to use existing protocols like OAuth and using basic SSL. Don't try to create security policies unless you really know what you are doing. There are companies who are doing their own security policies, but they know what they are doing. So if you don't know what you don't know about security that much, do not try to create your own security policies. Always use API keys over username passwords. Username passwords are not a secure way of handling authentication and authorization. Use API keys as much as possible. Caching. Use e-tags and use caching properly, because if you use e-tags and if you use cache properly, then you can save bandwidth. Specifically, if you are using if you are having mobile clients, you can use e-tags where the server sends an e-tag to the client, and if the client wants to check if the data has changed, it can use an if none match in the response body in the request header, and then the server can see what is the e-tag, because it has used an if none match, and has the data changed after the e-tag has been sent to the client. If not, the server can just send a 302 not modified status. Then what would happen is the client would know, okay, I don't need to get the data again, I have the latest data and they can use. So this saves bandwidth a lot. So use caching properly, and this implicit caching allows you to saves bandwidth or handle your uh, depending on the client, handle your clients much more better. Over a period of time, your API is going to change, so you will have maintenance. When you do maintenance, we have discussed about versioning. When you have versioning, when you have maintenance, always try to use HTTP redirects and abstract layers, where you give an abstract layer to the client, so the client connects to an abstract URI, not to a specific URI. And then if you are changing your URIs, if you are migrating, if you are doing version upgrades, you can do that behind the abstraction layer and your clients don't have to change. So for example, your clients may connect to api.restgateway.com/hotels, and then your internal implementation could be api.restgateway.com/hotels for v1, and which is residing in Europe. So you can have different entry points internally inside your abstraction layer, but your clients connect to an abstraction layer. And also you can use HTTP redirects. For example, if you're going from v1 to v2, don't have the clients changing to v2 until they are ready. You can just redirect all the clients who are coming to v1 to v2 by using HTTP redirects. And also use well-defined media types, which we mentioned when we mentioned about the URIs, where without saying v1, v2, v3 in the URI, try to use them in the request headers. So with that, we come to the end of some of the best practices that we have used in our APIs and which we have seen are not being properly used in other APIs. So the idea behind this presentation was to give some of the best practices that we are using, so you can develop your APIs with these in mind. And by doing that, it makes lives of clients like us who are developing against your APIs or your specs much more easier. And what to remember is this: your clients, when you're developing an API, or our clients, when we are developing our API, are the developers who are developing against our spec. So we have to make their life easy and make it much more easier for them. Happy developers who are happily developing against our spec means we have more clients. So in essence, by following these best practices, we make the life of each of these clients who are developing against us much more painless. So with that, we come to the conclusion of this presentation.